So hello, everybody.
Hello.
For those of you who don't know me yet, I'm working as a postdoc for Senckenbeck, which leads the work package number 4 of Geoessential. And this is work package focused on biodiversity and ecosystem workflows. I'm going to start with the rationale behind the workflow. I'm going to give you some details about the workflow development and finally let you know well, what kind of errors and limitations I found out. So within the Geoessential work package, but within the project, we have defined a criteria in order to select a workflow for the project dashboard, where the users will be able to interact with the product and retrieve information. In order to do that, the workflow should address an essential variable, a relevant policy, focused on agreed indicators, retrieve data from publicly available sources and produce an output, ideally use Copernicus, product, be scalable, and allow temporal comparisons. So on the deliverable 7.1, which you should be able to find it on the Geoessential website, you can see an example of the workflow that we have been working on. So in particular, the workflow that I'm going to show is related to the essential biodiversity variable ecosystem structure, which is one variable selected by GeoBond. And in particular, this workflow allows to estimate mean values of agriculture and forest fractional cover classes between 1992 and 2015, as you can see. And basically, we take the ESA CCI land cover products and we reclassify the classes, which are initially 38. And then we obtain rasters with agricultural, forest, and settlements. And then we just select a region, considering an input that should be provided by the user, and then we can estimate the average fractional cover for that specific area. In this example, you can see the case of Brazil and, well, the results of the well-documented deforestation policy implemented in the country since 2006. So the workflow basically is using, as I said, all these data sets from the ESA CCI land cover products. Then we reclassify them and we obtain the rasters with only 3 classes. Then we estimate the fractional land cover rasters, considering different spatial resolutions that can be defined by the user. In particular, we produce this raster at a spatial resolution of 3 kilometers or 30 kilometers, and then we compute the zonal statistics, and finally we obtain a product which is a data frame, a CSV file where you can see the mean values for a specific region for all the years considered. Doing so, the problems that we found were the following. Regarding GitHub, well, I tried at the beginning to upload the data to the repository, but there is a problem regarding the storage and the size of the repository. Then the solution was to upload the data to a Dropbox, but that produced as well some limitations regarding that. Well, the Dropbox links are not direct, so you have to change the ending of the links in order to be ingested on the VLab platform. And then another thing is that Dropbox, of course, has a limited amount of storage. And I spent one day with Mattia doing, well, the troubleshooting regarding that matter. And well, in the end, we both together got a model run which worked, but the following run produced errors that I will come back to that later. So regarding Docker, the problems that I found were related to build containers. Well, regarding the operating system that I have to use, which is Windows, and I think that I have a particular some problem regarding the firewall and the settings of my computer, I decided to do the analysis in a virtual machine, and I installed Linux there, and I could run the container and test the code, which was in, as you can see, in Python. But well, obviously this is not ideal because using a virtual machine, and well, I cannot work with the whole resources of my computer, and then I end up with memory problems. So in the end, what I could do is just a proof of concept of the workflow using only a subset of only 2 years, only 2 images, and a small region to test that the code was working. But another thing that I would like to discuss, perhaps if not today, perhaps in Florence, is related to some issues using Python in Docker containers and establishing the Python path and using and loading modules into the Docker containers, which didn't work. And finally, I just report you on some errors regarding VLab. Apart from the day that, well, I've been in contact with Mattia some other days, but we spent one full day working on all the errors regarding the inputs and the outputs on the VLab platform, and tried again to do some runs, but didn't work. And we finally got one output, but it was empty. So I need to do some research on what's going on and why the output on the VLab platform cannot retrieve the values that it should. And then finally, one of my concerns is that I try to analyze the VLab errors, but well, this is an example of the final error that I got yesterday, which it seems that the inputs were successfully ingested, that the output could be successfully produced as well, but finally I got an error. Perhaps you could help me to understand the meaning of that. So finally, in summary, I just present you that I developed a workflow that is meeting the criteria for the Geoessential dashboard, which is related to estimate and inform about ecosystem structure. And the limitations that I found are related to the operating system, memory storage, data inputs. I would like to know, perhaps in future, we could test how we could retrieve those data sets, which can be downloaded directly from the ESA CCI Landcover web service, directly perhaps into the VLab platform, and the errors that I encounter working with VLab. And that's all. And yes, please let me know if you have any questions regarding to what I just presented you. Thank you.
Thank you very much. It was very complete. I don't know, Mattia, if you want to react to some of these points already.
Yeah, well, I would go on with the next presentation, so maybe we can have questions and answers at the end. I mean, Marta was very, precise about all what she did, and of course there are some issues that we can face, which are technical. Some others are probably just a matter of explaining and documenting better what can be done. For example, the input ingestion, we probably should make it clear that all data which is accessible on the web can be ingested into VLab without any specific intervention. So this is, for example, when we say, for example, Marta says it would be nice to ingest data from the ESA portal if this data is available as a link, so with the downloadable link, that is already possible. But maybe this is not clear from our documentation, for example. So this is an input for ourselves to clarify this point. In terms of the errors, I completely agree that they should be more understandable for the final user. The list that Marta was showing is not something that a final user can understand. So definitely we should make this more clear. Also during the porting, when you have some, Marta didn't show, but when you have some validation issues, sometimes the error is not, is not clear, and so we need to enhance that. In terms of other limitations that were presented here, for example, the repository size, that is something that in general is not something that we find, in the sense that code repositories are usually quite small size. When when you add data to the repository, then of course the repository size increases, and this can slow down all the process of porting and of course of executing the model, generating sometimes timeouts over HTTP and so on. But that is something that in general I think is fair to assume that it is not happening, because the code itself is not big in size. And then, of course, there are some issues related more to the Docker technology, which is a very nice technology, allows a very high level of portability, but of course it has, let's say, a learning curve if you have never used it, and especially on Windows, you might have some issues running Docker on your machine. We are collecting all of these and trying to have a list of suggestions for Windows users as complete as possible. But in general, I think that the experimentation with Marta was very useful to understand more in depth what are the needs from the modelers, and to enhance a set of things, both documentation and sometimes the technical stuff. Then we can have more in-depth answers later, maybe if others have questions.